Now here we're going to look at the vertical line test in the domain and range. The vertical line test is used to determine whether the graph of an equation represents a function or not. And then we're also going to look at determining the domain of the function and the range. So here we're given the function f of x equals x squared minus 5. So here, let's look at the domain first. If we want to find the domain of this, remember that is our x value. So we want to know what values can x take on. And this is a polynomial function, simply x squared minus 5. And you recall this would simply be all real numbers is one way we could state the domain, or we could simply say it's negative infinity to positive infinity. All right, now before I look at the range, I'm going to look at the graph of this function. I think will be easier to determine the range. The domain we can easily tell from the equation in most cases, but the range sometimes it's a lot better to look at the graph. So here we're going to graph x squared minus 5. So if I go to the calculator, we can go to y equals, type in x squared minus 5, and again I always like to start with zoom 6, which is zoom standard. And here we have a good representation of our graph, which is a parabola. So if I copy this, okay, here, once again, just as a reference, we're going from negative 10 to 10 on the x and negative 10 to 10 on the y-axis. And we can clearly see that our domain, which is our x values, notice this graph goes up to the left, so it's going to continue to go up to the left and in the left direction. So that would be our domain over here, which is negative infinity, and it's always going towards the right, so that would go to positive infinity. So if we want to determine the range, then we want to know what is the lowest point on this graph. Does this graph continue to go down to negative infinity, or does it stop? Well, hopefully it's obviously the graph stops right here, and that is at 1, 2, 3, 4 at a negative 5. So in other words, the smallest y value that we're going to have for the range here is a negative 5. Now, of course, the graph goes up forever, so it's going to go up to a positive infinity. So we would say that the range, now because we're talking about a y value, we could say that the range is y is greater than or equal to 5. And another way of stating that would be because, whoops, I'm sorry, not 5, but negative 5. Y is greater than or equal to negative 5. And we could certainly use the interval notation where we say negative 5, comma, infinity. Okay, so there's the domain and range. Domain is all real numbers. The range is negative 5 to positive infinity. Now we want to look at using this vertical line test. And for the vertical line test, we're simply going to draw vertical lines anywhere along the graph. If I draw a vertical line anywhere through here, how many times does each vertical line cross the graph? Well, if we notice, it's only going to cross the graph each time at one point. So if you can draw a vertical line anywhere on the graph and it only crosses at one point, then that tells us that this is going to be a function. Okay? Now, the other thing I want to go ahead and talk about is identifying our zeros. We've talked about that before. That's what makes our function equal to 0. Well, if we look closely here at the graph, our zeros is going to cross the x-axis right about here and right about here. Now, unfortunately, it doesn't cross right at a point. In other words, it looks like it's very close to a little bit more than, 2, but not quite 3. So it looks like maybe 2.2 or something. So this is where we could actually take our function x squared minus 5 and simply set that equal to 0 and solve for x. So if we do that, we end up with x squared equals 5, and then x equals plus or minus the square root of 5. And that's where we have our 0. So this point here and here would be negative square root of 5 and positive square root of 5. All right, our next equation, we have x minus y squared equals 1. And once again, to start off, we want to determine the domain. Now, before we start with this, we may want to solve this equation for y. That may make things a lot easier for us. So here, I'm going to take and move the x over. So we have a negative y squared equals negative x plus 1. And if we get rid of the negative, then we would have positive y squared equals x minus 1. So all I did was multiply everything by a negative 1. And now to get rid of the square, we take the square root. So that means we're going to end up with, again, plus or minus the square root of x minus 1. And if we go to calculate the domain, can we do that from looking at the equation? Well, once again, we have this square root, so we know that x minus 1, right? If we think of the x minus 1, that has to be greater than or equal to 0. So if we solve for x, x must be greater than or equal to 1, and that's going to be our domain. Or we could simply say 1 to infinity, okay? Now, you don't have to write both of these answers. You could write either one. X is greater than or equal to 1 or 1 to infinity. So if we plug anything less than 1, you're going to end up with a negative, and we cannot take the square root of a negative number. Now, once again, to find the range, let's go about graphing this in our calculator. Now, be careful. We have a plus or minus the square root of x minus 1. So we go to y equals and clear out the other one, and we're going to type in the square root of x minus 1. And now if you notice, if I hit graph, all right, we get part of the graph here, but remember this was actually plus and minus, so here we had plus or minus the square root of x minus 1, so that means here we need to go to y equals and go to y2 and type in the square root of, whoops, type in the negative square root, okay, when we put a negative in front of it, x minus 1. And now when we look at the graph, notice we get the top part of the graph and the bottom part. So there's the negative square root on the bottom. So again, I'm going to copy this. And if we look at the graph, once again, this is negative 10 to 10. And looking at the graph, we can see that the smallest x value that we have is right here at 1, and then it goes all the way over here, continuously going to the right, so it's going to infinity. So our domain is correct. Now, what about the range? What is the smallest, if we go down here on the y-axis, what's the smallest value we get to? Well, if we notice, the graph curves here and it's constantly going down, so it's going to go down to negative infinity. And then the top part of the graph is constantly increasing, so it's going to continue to go to positive infinity. So our range would be negative infinity to infinity. Or we could simply say it's all real numbers. And then again, if we look at our vertical line test, we want to determine, do we have a function? Well, if we use the vertical line test, if I draw a vertical line, well, if I draw one right here, what happens? It crosses the graph twice, so therefore this is not a function. Okay, so here this equation is not a function, and we probably knew that from when we solved for y, because what do we have? We have plus or minus. This right here being plus or minus tells us that we're going to have those repeated x values. So in other words, one x value is giving you two different y values. So therefore this is not a function. All right, and let's see if we can calculate the zeros, and that is where the graph crosses the x-axis, and it looks like we're going to have 1, 0 right here on the x-axis. And if we take our equation, we want y to be 0. So if we go up here, we have x minus y squared equals 1, so x minus 0 squared equals 1. So therefore, x equals 1 is our 0 right here. So that would be the point 1, 0. All right, our next example. X squared equals 2xy minus 1. Can we determine the domain? Now this may be a little bit harder to see. Now if we're looking at determining our domain, once again, if we solve this equation for y, we would end up with x squared plus 1 equals 2xy. And then if we divide by the 2x, we're going to end up with x squared plus 1 over 2x equals y. Over here, the 2x would cancel out. So I think we could easily determine the domain here. We have a fraction, and if we look at the denominator, clearly if x is equal to 0, the whole denominator is going to 0. So therefore, it looks like our domain is going to be all real numbers, except x does not equal 0. Okay, or we could certainly say negative infinity all the way to 0, and then we're going to skip over 0, or, and this is the union symbol you'll see, we could read this as union, or the word or, 0 to infinity. So either one of those would represent the domain of this equation. Now once again, if we go to calculate the range, until you get really familiar with these equations, it's probably going to be best to put this into the calculator. So if we go to y equals, and we want to clear out our previous equation here, and the equation we had was x squared plus 1 over 2x. So I'm going to put parentheses x squared plus 1, close parentheses, and this is all divided by parentheses 2x. Now the reason I put parentheses around this, I want to reemphasize that when you're looking at typing in division, we want to take the whole numerator, x squared plus 1, divided by the whole denominator. So if you're ever unsure, it's best to go ahead and use parentheses. So then if we type in graph, we have the graph of our equation here. And I'm going to copy this. And if you notice here, we have our equation, have our graph, negative 10 to 10 on the y, negative 10 to 10 on the x-axis. And once again, we can tell that our graph is going to split. So if we notice, it splits right here at the origin. Part of this graph continues to go up. Now, the calculator looks like the graph stops here, but this graph actually continues to go up, but it gets ever so close to the y-axis, but it will never touch it. And this part of the graph here continues to go down. And again, it's going to keep getting closer and closer to the y-axis, but it will never touch or cross the y-axis. And that's because here, our domain, it cannot be equal to 0. So that's why the domain here is going from negative infinity all the way up to 0, and then it's going to skip over 0 and go to positive infinity. Now, what do you think is going to happen here with the range? Well, if you notice, the graph of this function stops. If we go from here, start over here to the left, it's going up, and at this point right here, our graph stops, and that point happens to be what? Well, this right here looks like this is going to be a -1, and then there's no graph from -1 all the way up to this point right here, which looks like a +1. So it looks like our range is going to be -infinity up to -1. So we'd have -infinity up to -1, including -1, union, or then it skips up to 1 and then goes all the way up to infinity. So this here would be the range for this particular equation. Now, if we use the vertical line test, we want to determine, is this equation representing a function? Well, if I draw a vertical line anywhere through here, notice it's only going to cross once. Now be careful, I know a lot of people get confused here, and it looks like if I draw the line here, you're thinking it's going to cross, but remember, this graph is always moving over closer to the y-axis, and even down here on the bottom, it's moving closer and closer to the y-axis. So when you draw the vertical line, it's only going to cross once. So yes, this is representing a function. And we could determine that over here as well. When we solve the equation over here for y, we got y equals x squared plus 1 over 2x. And we only have one x value for each y value. So therefore, we do have a function. All right, so hopefully you have a little bit better idea of how to use the vertical line test and how to find the domain and range. Again, a lot of times the domain can be found from simply solving the equation for y, and the range can be found by looking at the graph. And remember, you're just looking at the range. How far down does the graph go? If it stops, then that low point is the smallest y value, and then if it continues to go up, that would be infinity, or wherever the largest y value is. If it stops, then that's going to be the maximum part of your range.